First problem on the worksheet. Number 1, related rates worksheet. Okay. Question says a machine is rolling a metal cylinder under pressure. Okay, before I go any farther, let me give you a real-world example of this. You probably have never used a machine to roll a cylinder under pressure, but I know that almost every single one of you in this class has done what I'm about to say. Okay, have you ever opened a brand new can of Play-Doh and dumped it out? Yes. Okay, what shape is the inside of a Play-Doh? It's a cylinder. Okay, you put it in your hands and you start going like this. Okay, you're rubbing it together. You're rubbing it together like this. Okay, as you rub it, is the radius increasing or decreasing? The height is? What's the volume doing? It's staying the same, isn't it? So what's happening here is they have a cylinder of metal that's between two hard plates that are rolling it together the same way when you roll Play-Doh. Okay? The machine is rolling the metal cylinder. The radius is decreasing, like we said, at a constant rate of 0.05 inches per second. And the volume is 128 pi cubic inches. And we said the volume doesn't change, correct? At what rate is the length h changing when the radius is 1.8? Here's your formula. All right. Step 1 is to identify all the numbers in your problem. First number we come to is this 0.05. And because it's inches per second, 0.05 inches per second. Is it going to get a dt or not? Yes. So equals something over dt because it's inches per second. And it goes back and look, it says the radius is decreasing at a constant rate. So what should it be? D what? dr, because it's radius. dr dt. But that was the next question I was going to ask. Why should we make it negative? Because it's decreasing. So yes, it should be negative. Because the radius is getting smaller when you roll it. Okay? What's the next number? The 128 pi inches cubed. Is that dv dt or just v? That's just v. Okay? Now it's starting to ask the question, at what rate is the length h changing? So find a rate, so it's dt, and it tells you to use h. Well, that's kind of nice of them. Find the HDT when, because there's always a stipulation, the radius r is 1.8 inches. I was right to write centimeters. Okay, we've identified all the numbers. Is everybody with me so far? Okay. The next step is to write your equation. Well, they were nice enough to furnish that for us. So V equals pi r squared h. Okay. Now, just like the last one, we are going. Now, this one actually gives me and finding the HDT, so those are supposed to both stay there. Okay. We're going to go ahead and take the derivative of this using the product rule, like we did a minute ago. And I know what you're going to ask me. What are you going to ask me?
I was going to ask, like, if v staying constant, you take the derivative of v.
Okay. There's two ways you can do this. Now, since I already know what number v is, and it's constant, can I plug it in right now? Yeah, why don't we do that? So this is 128 pi equals pi r squared h. Now, actually, this is going to make my life a whole lot simpler, because what happens to the pi's? They cancel. So now I have 128 equals r squared h, and I need to take the derivative of that. And I am still going to use product rule, but what's the derivative of 128? 0. Does it make sense that the derivative of the v turned into a 0? Okay. Because remember that the derivative of v is the change in volume. How much is the volume changing? Not at all. Okay. So that's why this is now a 0. Equals. Now let's do product rule right here. So copy 1, r squared, times, what do I write for d2? dh dt. Plus, copy 2, h, times d1. The derivative of r squared is 2r dr dt. Okay, I want to wait just a minute. Is everybody understanding what I just did? Okay, 1D2, 2D1. Okay, now let's start plugging stuff in. Let's hope we got everything. 0 equals R, oh yes, I've got R, 1.8 squared. dH dt is what I'm solving for, so that gets written down. Plus, ooh, I don't know what H is.
Do you solve for it?
You solve for it. You use the equation that you're taking the derivative of, go back before the derivative, and you can solve for the H. So I'm going to come out here and do V. Actually, I've already started it, so let's do it this way. V equals pi r squared H. Plug in the 128 pi here. Equals pi. R is 1.8 squared H. Once again, cancel your pi's. So I need a calculator, and I need to do 128 divided by 1.8 squared. 128 divided by 1.8 squared. And I get H equals 39.506. So that's what's going to go right here, 39.506 times 2R. R is 1.8 again. And dr dt is my negative 0.05. Okay, so now I've gotten rid of everything except the variable I'm looking for. So now I need clean. I'm going to need my calculator back again. Whoopsie, don't fall. So 0 equals 1.8 squared is 3.24 dH dt plus, multiply all that together, 39.506 times 2 times 1.8 times negative 0.05, whoops, 0.05 equals negative 7.111, 3 decimal places. Can you now solve for dH dt? Move the 7 over. 7.111 equals 3.24 dH dt. And then divide. 3.24. And it's going to be off by just a little bit. 7.111 divided by 3.24 equals 2. No, it's actually going to be right this time. 2.195 if I round it. And if you look at the answer choices, you will see that is C, and that's the one that I want. But I still need to write a sentence. The height, is the height increasing or decreasing? Is increasing at a rate of 2.195. Now the radius is increasing in inches per second, and so is the height when r equals 1.8 inches, and we are done.